Determine closed-loop gain margin and closed-loop phase margin using the Ti-89 calculator for this closed-loop system, where GH is given and was used in previous videos. These values of closed-loop gain margin and closed-loop phase margin were determined by MATLAB in previous videos. The denominator of GH can be expanded in the S domain. GH can be expressed in the j omega domain by substituting j omega for S. Enter y1 as the real part of the denominator using the function editor where x is omega. Enter y2 as the imaginary part of the denominator using the function editor. Enter y3 using the function editor, which is another way to express GH in the j omega domain. Enter y4 using the function editor, which is the angle of GH of j omega in radians. Enter y5 using the function editor, which is the magnitude of GH of j omega. Pause the video now while you enter these 5 functions, and also enter the values of A and B. This is the Nichols plot of GH. This is the closed-loop phase margin, the distance between those 2 points. Calculate the frequency omega 1 at this point. Omega 1 is x. Since 0 dB is equal to 1, determine x where y5 equals 1. Somewhere in this table, y5 is 1 between x is 0.9 and x equals 1. A graph of y5 can be used to find a more accurate value of x for y5 equals 1. Using these window values, a Ti-89 plot shows y5 equals 1 when x equals 0.9223. y3 has magnitude 1 and angle negative 148.3 degrees at that frequency. Closed-loop phase margin is the difference between those 2 angles. Closed-loop phase margin is 31.7 degrees as determined by the Ti-89 calculator. Closed-loop gain margin. Calculate the frequency omega 2 at this point. We'll call it x. Since the phase of GH is negative pi at omega 2, determine x where y4 is negative pi. This table of values shows x is somewhere between 1.8 and 1.9. A graph of y4 can be used to find a more accurate value of x for y4 equals negative pi. Using the window values, a Ti-89 plot shows y4 is negative pi when omega 2 is 1.817 radians per second. y3 at this frequency has magnitude 0.303 at angle negative pi. 0.303 has a dB value of negative 10.36. Therefore, the closed-loop gain margin is 10.4 dB as determined by the Ti-89 calculator.